We're in section 5.6 here, and we are going to do another definite integral using a u-substitution. So here's our integral this time. It's the integral from 1 to 2 of dx over 3 minus 5x squared. Okay, one thing FYI, if you don't like seeing that dx in the numerator, just put a 1 there instead and put the dx on the outside of the fraction like this. Okay, 1 over 3 minus 5x squared dx. That is totally fine. Okay, so we got to think about now what we would want our u-substitution to be. And let's see. Now, if you can spot one, go ahead and do it. There's maybe not the clearest pairing of like function and its derivative sitting here. So remember our trick to focus on the part that's making this more complicated. I'd say that's the fact that we have some stuff in parentheses getting squared down here. So I'm going to opt to make this stuff inside the parentheses into my u. That way it'll simplify that denominator. That's often a good trick. Look inside parentheses or underneath radicals, things like that. Usually the stuff inside of those is a good choice for the u. So I'm going to let u equal 3 minus 5x. And you know what's next. We're going to take the derivative. Du dx would be just negative 5. And so du would be negative 5 dx. Okay. Now notice that we do not have negative 5 dx sitting around there. There are different ways to approach this, definitely. So if you pick up another method, that's fine, by the way. Just show all your work. It's fine. So this, I'm going to say, look, we've got dx here rather than negative 5 dx. So I'm just going to choose to say negative 1/5 of du is going to be equivalent to dx. And so that's what I'm going to substitute in instead of dx there. Okay, so there's how I'm going to make my substitutions. And now remember that we also need to deal with the limits of this definite integral, our limits of integration. And there are two options. You can either convert the limits to values of u, or you can keep placeholders, do the integral, and then put the limits of integration back on once you're back in terms of x. So for this time around, I'll do it both ways for you. So I'm going to choose the option of switching the limits this time around. Or I guess convert the limits would be a better way to say this. Convert limits to u values. Okay, so our upper limit of integration, x equals 2. U is going to equal 3 minus 5x. So 3 minus 5 times 2. That'd be 3 minus 10, which is negative 7. And then the lower limit, x equals 1, u would equal 3 minus 5 times 1, and that would be negative 2. Okay, so in doing that, I think I have converted everything on the integral here. So now in terms of u, this is going to be the integral from negative 2 to negative 7. Make sure you keep those limits of integration in the same location that they originally were. X equals 2 was the upper limit of integration, so u equals negative 7 should still be the upper limit, even though negative 7 is less than negative 2, all right? It should still be in that upper position. We are just converting the numbers. Okay. So there's our limits, and then we would have, here's our u down there. So we would have 1 over u getting squared, and then dx here is going to get replaced with negative 1/5 du. Okay, just like so. All right. Now a little bit of cleanup on this. I'm going to go ahead and pull this constant, -1/5, out to the outside of the integral. That is one of our properties of integrals. So -1/5, integral from -2 to -7, and then 1/u² would be u to the -2 du. All right. Now this integral is at a nice place where we can take the antiderivative. That's the goal here. Okay, so -1/5 antiderivative would be -u to the -1 power. Make sure you ditch that du once you do your antiderivative. You don't need that anymore. And put our limits of integration on here. Since these are u values, -7 and -2, that means we're going to be able to plug them in directly to this antiderivative we've found. That's why we don't want to leave x values on this thing. Otherwise, you might be trying to plug x's into a u-shaped hole, and that does not work. Okay, so got -5. I'm going to rewrite that, -1/u. And then I'm going to plug my limits of integration in. Okay, so first upper limit, -1/-7, and then minus, plug in your lower limit, -1/-2. Whole lot of negatives going on here. We got -1/5, 1/7. Oh, that would be -1/2. Okay. Get yourself a common denominator for those terms inside. 2/14 minus 7/14. And we'll have negative, oops, got a little ahead of myself, -1/5 times -5/14. Okay, and then when we do that, we will have +1/14 for our answer. Okay, so that is the solution for this definite integral. All right, notice how we never went back to x at any point during this strategy, since our integral was in u and our limits were in terms of u. We never needed to go back to x. We still found the correct answer, but we didn't have to switch our variable back. Okay. Now, let's see, let's do this same problem, but let's use the other approach where we don't convert the limits. Okay, so same problem, 1 to 2 dx over 3 minus 5x squared. Okay, you would probably again start out with separating that dx off there. Most people prefer to see it this way, but you can actually convert just fine leaving the dx in the numerator. That's fine. And since we just did this one, we kind of know what u is going to need to be. And we're still going to get that same derivative, same differential, du equals -5 dx. And I would still convert this so that I can see what dx is. That way I can replace it more easily. Okay, now we're going to do this using the option of not converting the limits. Okay, without converting limits. All right, and I'm just writing that as a note for us. You don't have to write, hey, I'm doing this without converting the limits. I'll see that you're not converting the limits. Okay. So we're going to convert this integral into terms of u, and it would go very much the same as before. 1/u² times -1/5 du. But now, since we are not converting limits, do not put those x values on here. don't go like this, because then you'll trick yourself into thinking that this is u equals 1 and this is u equals 2, which we know is not the case. Those are x values. So don't put them on there. Don't do it. Okay. Put some sort of placeholder there. u1, u2, or x1, x2. That's fine. Just anything to remind yourself that these are not the actual limits here, 1 and 2, while we're working with this other variable. Okay, I think you get the point. All right, so you would then have your integral in terms of u with your placeholders, and that would allow you to take the antiderivative, because remember, that is really our goal with these u substitutions, is to make taking the antiderivative easier. Okay, and so we'd end up here. All right. But now here, since we didn't convert our limits, we do need to switch back to the original variable and use the limits from that original variable problem there. So we need to switch back to x. I'll make a little note here. Back to x. Okay. Nothing happens to that constant out front. But here inside, your u would get replaced back with 3 minus 5x, because that's what u is. Okay. And now that we are back in terms of x, you can put your x limits back on there, 1 and 2, and then we're going to plug those in. So negative 1/5, and then plug in that upper limit of 2. So negative 1 over 3 minus 5 times 2 minus negative 1 over 3 minus 5 times 1. Okay. Notice that, yeah, ultimately we do end up doing the same calculations as we did with the option where we converted limits. We just do them in a different stage of the problem, and that's fine as long as it gets done. Okay. There we go. And so we're ending up with the same values here. Negative 1/5 times 1/7 minus 1/2. And algebraically, we know what's going on there. This is still going to equal 1/14. Okay, so same thing. All right. So there's both options, converting the limits or not converting the limits to approach this integral.